Okay, grade 8. This is chapter 11, lesson 2. We are learning about parallelograms, okay? That's the symbol for parallelogram. That's what lesson 2 says. See? In chapter 11. Now, how do we classify parallelograms? Parallelograms are classified as irregular polygons because all its sides are not congruent, okay? And then here, it is also a convex polygon because there's no angle going inside, okay? All the angles face outward. All right, now let us discuss some features or some properties of, remember when you see the word features, we mean properties, like that. So what do I mean by that? What do you see when given a parallelogram, okay? So we know a parallelogram is a quadrilateral because it has 4 sides. We also know that it has 4 interior angles, okay? We know that the sum of all the interior angles add up to 360. Because n is 4, if I do this formula, I should get 360. Or when I cut the parallelogram into 2, you have 2 triangles. One triangle is 180, the other one is 180. 2 180s is 360, okay? We know that the opposite sides must be parallel. So in this parallelogram, parallel means the 2 lines cannot meet. So the opposite sides must be parallel. EF is parallel to HG. HE is parallel to GF. I didn't say all of them are parallel. I said opposite sides are parallel. Opposite, okay? That's why I didn't use 2 arrows here. These 2 are the ones that are parallel and these 2 are the ones that are parallel, okay? Remember the parallel symbol? We learned it in lesson 1. In lesson 1 of chapter 5, in term 2, okay? So this is the parallel symbol. So we are saying EF is parallel to HG, you write it like that, and EH is parallel to FG. All right. We know that the opposite sides must be congruent. They must be congruent. EF is equal to HG. If I write 8 here, I will write 8 here. Opposite sides of a parallelogram will always be congruent. Always. If I write 3 here, this must be 3. Okay? Now, if you know the, sorry, we're here. I'm mixing my papers. Wait. I put them nicely. Okay? So we've talked about congruent sides. Opposite sides must be congruent. We go to the next one. So the 6th property is opposite angles in a parallelogram are congruent. And this is always. Always. This is important. So angle L is congruent to N. Angle M is congruent to P. That's all I wrote. Remember, you can use 1 letter for the angles. You can use 3 letters for the angles. P, L, M, I am talking about angle M. I am talking about the letter in the middle. P and M, I am talking about N, the letter in the middle. We have said here L is congruent to N, the same thing. Okay? M is congruent to P. If you write 100 here, you should write 100 here. If you write 30 here, you should write 30 here, like that. Okay? Opposite angles must be congruent. Now, consecutive angles should add up to 180 because they are supplementary. So, the consecutive angles must be on one side. They must be on one side. So, L is consecutive to P. P is consecutive to N. N is consecutive to M. M is consecutive to L. So these 2 are consecutive, these 2 are consecutive. These 2 are consecutive, these 2 are consecutive. Okay? You remember? And LP is a transversal because LM and PN are parallel. So remember when we did this in lesson 1. This is your transversal. This is your parallel lines. This angle and this angle, we call them consecutive. All we are doing now is erasing this part. That's all we did. Okay? Now, consecutive angles in a parallelogram are supplementary. That means they must add up to 180. So, L plus P, 180. There, L plus P. M plus N, 180. P plus N, 180, 180. Like that. They will always add up to 180. All right. If one of the angles is a right angle, then the other 3 angles must also be 90. If one of the angle is 90, if I write 90 here, then everybody else must be 90. That is the rule, okay? So if one of the angles is a right angle, then the other 3 angles must also be 90 degrees. So all the 4 angles must be 90 degrees. And this is an example of a paragraph proof. You must know how to write proofs. You must know how to write proofs in a paragraph. You must know how to use the 2-column table to write proof. You must. So here is an example of a paragraph proof. Okay? Here is another example. I will continue. Now, in a parallelogram, you have diagonals. Remember, diagonal going up, diagonal going down. So, you have a diagonal going up and you have a diagonal going down. You have 2 diagonals. You only have 2 diagonals in a parallelogram. Only 2. Now, the diagonals in a parallelogram are sometimes congruent. Not always, sometimes. It depends with the type of parallelogram. So now you should ask yourselves, what are the types of parallelograms? Do we understand? So you need to ask yourself that question. So not always will this be the same. Not always. PR and SR will not always be the same. It depends with the parallelogram. Now, the diagonals in a parallelogram bisect each other. This is always. This one does not depend with the parallelogram. So this is always. Bisect means to cut into 2 equal parts. So I am saying WC is the same as CU. I am saying TC is the same as CV. That's what I am saying. Because the diagonals, when they meet, they cut each other into 2 equal parts. Okay? So that is what you're going to write. Alright, make sure you write this and not always. Don't just write this and then say not always. You must write these 2 things. Alright, if a quadrilateral is a parallelogram, then each diagonal cuts the parallelogram into 2 congruent triangles. That means if I draw this diagonal, this triangle here is the same size as this triangle here. So that is why I said triangle XYZ is the same as triangle WYZ. So these 2 triangles are the same. Okay? This means if you know the area of one triangle, it will be the same area as this. If you know the area of the parallelogram and you want the area of one triangle, you just divide it by 2. So that's what I wrote over here. This means if you know the area of the parallelogram and you divide it by 2, you will find the area of one triangle. So area of one triangle equals area of parallelogram divided by 2. Then I just wrote the name of the parallelogram and I divided by 2. If you know the area of one triangle, then to find the area of the parallelogram, you just multiply the area of that triangle by 2 because there's 2 same triangles in the parallelogram. And that's what I wrote. Area of parallelogram equals to area of triangle times 2. Okay? You should know also how to find the area and the perimeter, because you never know what question will be asked. So, from grade 6 or grade 5, I think grade 6 and grade 5, to find the formula of finding area of a parallelogram. Area of a parallelogram is given by base times height. So when you draw a parallelogram, these lines, the longer lines, not the shorter ones, the longer lines. The base is the longer line in the parallelogram. So the longer line is what you're calling the base. So the base, you must multiply with the height. The height must be vertical. You cannot use the diagonal line and call it the height. The height will always be vertical and perpendicular to the base. So if I extend my base where it meets the height, there must be a 90 degree. So for you to find area, you multiply base times height, and there. So now the formula for finding perimeter, just add all the sides. So if I want perimeter of a parallelogram, I will do FG plus GH plus HI plus IF. That's all I wrote. Perimeter, I put my side lengths, I put my dimensions, I added my dimensions, and there is my answer together with the units. Don't forget this is unit squared. Okay? So that's how you find the perimeter, and that's how you find the area. Perimeter, you use all the sides. You don't use the height. You just use the sides. You must know the height to find the area. If you don't know that, if they gave you this diagonal and they gave you this line, then use Pythagoras theorem to find the height. Remember, this is a right triangle right here. Okay, if you don't know one of them, you need to use Pythagoras theorem. Okay. All right, we are done there. Okay, now, they will give you parallelograms on a coordinate plane, something like this. Okay, they'll give you points for each corner. They may tell you to draw, it may already be drawn, or they just give you points without drawing. So, the first question they can ask you is find the length of W, X, Y, Z. So they're asking you to find the length of this parallelogram. So that means find the length of WX, find the length of XY, find the length of YZ and ZW. If you know WX, then you don't need to do ZY because opposite sides of a parallelogram are the same. If you know WZ, then you don't have to find XY. You only find the opposite one. You find the horizontal and the diagonal. Or the diagonal, or depending on how your shape looks. Only one of each side. And then the numbers will be the same for the opposite sides. So how do I find WX? Because it is horizontal, I will count the spaces between W and X. Or I will use the formula absolute value, X2 minus X1. Because it is like a number line. Because it is horizontal. Now, if I count from here, this is -1 and I am going to 8. So -1 to 0 is 1 space. 0 to 8 is 8 spaces. Altogether is 9 spaces. So the distance from W to X should be 9 units. Okay? Now let's use the formula to confirm. I wrote my points. W is -1, 7. X is 8, 7. I took my X's because that's what my formula needs. Then I apply. X2 is 8 and X1 is -1. When I subtract, I have 2 negative in the middle. It becomes positive. 8 plus 1 is 9. Absolute value of 9 is 9. And then I wrote my units. Now, XY is diagonal. Since it's diagonal, we are going to use the distance formula. You apply the distance formula. I got 9.22 units. Okay? I labeled my work, X1, Y1, like that. I plugged in my numbers. That's what I got. Then I wrote my answer. The question was, find the length of the parallelogram. So that means I need to have 4 lengths. 2 the same, 2 different. Each 2 the same. Then I wrote my letters that represented the segments. So WX, I wrote the units. And this is the answer to this question. The question can also be asked. You may be given the same picture and asked a different question. Find the diagonal length of the parallelogram. So, remember in the beginning we said, sometimes they can be the same. Sometimes they cannot be the same. Okay? Now, you do the same thing. Because they're diagonal lines, you use the distance formula. You have WY, WY, and you have ZX. So you take your two numbers, you take your 2 points and you label them X1, Y1, X2, Y2. The same thing here. And then you do your distance formula. Now, I got 130 here and I got 202. So you see, my diagonal lines are not the same. Make sure you change them to decimals. Don't leave them as square roots like me. I don't know why I stopped. Square root of 130, 11.4 units, square root of 202, 14.21. So yes, make sure you write your numbers in hundredths. 14 and 21 hundredths units. What was square root of 130? Oh yeah, 14.40. Okay. So they are the diagonals of my parallelogram. All right, we move on. Another question you can be asked, determine the coordinates of the intersection of the diagonals of the parallelogram. This formula is asking you, this question is asking you, find the midpoint. That's what it's asking you. Find the intersection means find the midpoint. And you remember the midpoint formula. The midpoint formula is xm equals to x2 plus x1 divided by 2. The ym is y2 plus y1 divided by 2. You plug in your numbers and you get them. Okay. Now, when you plug in your numbers and you do for wy, you must check with zx. So if you do wy, the check must be the other line. And your answers must be the same. If your answers are not the same, so the answer you get when you do midpoint for zx should be the same answer you get when you do midpoint for wy. If those two answers are not the same, they are wrong. I am not saying here it happened ours are the same. Here. I did not say xm and ym must be the same. I said the answer for wy should be the same as the answer for zx. So I did my values, and here is my midpoint. I wrote it as a fraction, and you can write it as a decimal. Okay? So now let us do the check. And as you can see, I did my work for the check, and my answers are the same. So xm here is 5/2, it's 5/2. Ym is 5/2, 5/2. Okay? All right, now let's do some examples. This is example 2 in your book. It is over there. Also, before I forget, make sure you write this one, this 2-column proof. Write this in your notebook. Okay? That is how you explain the column proof of a parallelogram. Now, we are doing examples now. Now, in this example, they told us to find the value of each variable. The variable is x. I can do this two ways. Opposite angles are equal. Consecutive angles are add up to 180. So, method 1, I say they were equal. 2x minus 1 is equal to the opposite, which is 75. Then I solved my equation. I subtracted. This goes away. I am left with 2x. I divide, I got that. For me to check, I can do method 2 to make sure my answer is the same. Consecutive angles will add up to 180. And there, I did 105 plus 2x minus 1. I put my friends together. 105 and negative 1 are friends. I got 104. I subtracted 104 on both sides. And then I divided by 2. I got the same answer. Okay. Example 3. We know opposite sides are congruent. So I wrote QR is equal to TS. Then I substituted QR with 11, TS with y minus 4. And then this is negative. Opposite of negative is add. Additive inverse becomes 0. I added on both sides. And y is that. Then I checked. And I found that, yes, 15 minus 4 is 11, which is the same. And here is my paragraph proof. I always tell you, write, explain. This is your proof, how you know. Okay? Question 4. I was doing these questions. They're in your books. I didn't get the questions from anywhere else but your books. There. Where is it? Here. Almost there. These are the questions I was doing from your book. Okay? All right. So, question 3, I did. So, question 4, we are doing bisectors. Y, P. If they don't give you this middle point, put P in the center. If P is one of the letters outside, choose another letter. Okay? Now, YP is the same as PX. Then you write that. And WP is the same as ZPZ. So, 10 is equal to 2b minus 6. And 2 is equal to a minus 7. That's what I wrote. Then I solved for b. Then I solved for a. Then I wrote my paragraph proof. Because they are bisectors of diagonals WZ. And bisectors in diagonals of a parallelogram are congruent. That's the reason why I could do this. Okay? Then, the last one is the same one for the bisectors. So, remember when you're using bisectors, choose the same variable. You cannot say 3b is equal to 2w. These letters are not the same. How will you solve? You can't. So, this b will go with the b's. These w's will go with the w's. Okay? That's exactly what I wrote over here, using my picture. I wrote 4w minus 7, and then I solved, and I got my w. The same thing here. I didn't do anything different. I put my b's together as equals, and then I solved. Remember, letters on the left, numbers on the right. So the letter on the left, you move it to the right by doing the opposite. It is positive, you be right negative. The same thing here. 4 minus 2, 2w. Bring down negative 7. Opposite of negative 7, positive 7. You do it on both sides. This one is called addition property of equality. When you add, addition property of equality. When you subtract, so this is subtraction property of equality. Subtraction property of equality, because you're subtracting the same value on both sides. This one, addition property of equality, addition property of equality, and this one, division property here. Because you're dividing both sides by the same value, division property of equality. So here you're using these properties to help you solve. And that's it. Read carefully. When you don't read carefully, life will not be easy. Okay? Alright. So do Aleph. See you on Sunday, inshallah.